Just as we were able to find a confidence interval for a proportion, we can also find a confidence interval for a mean based on a sample guess within what range of numbers we are quite confident, 95 or 99% confident, the actual mean of the entire population is going to fall. The process we're going to go through to find a confidence interval for the mean is almost exactly identical to how we found the confidence interval for a proportion. The only difference is we have a different formula to calculate the error bound. The error bound we're going to do with the t sub alpha over 2, or the critical value from the t distribution, which we can find on Excel, multiplied by the standard error, which is the standard deviation divided by the square root of n. Once we have that, we can quickly calculate the actual confidence interval the same way we found the confidence interval before. We take our point estimate, which is the mean of the sample, and subtract the error, and our point estimate, the mean of the sample, and add the error to get our confidence interval. Now, Excel is nice because it can actually tell us what the error is directly. So let's look at the direct Excel command to find out what the error is actually equal to. The error is equal to confidence dot t, and then we'll do an alpha SN, where alpha is the area in both tails, S is the standard deviation of the sample, and N is the sample size. And that command's really going to do most of the work for us. So if we had an example where we have a sample of 29 families that found an average of 3.2 children per family, with a standard deviation of 1.8 children. We're going to make a 95% confidence interval. Well, first we need to know how much error there might be between our sample result and the population result at the 95% confidence level. And to do that, we'll do that on Excel with confidence.t. We'll need the alpha. And so if I think about wanting a 95% confidence interval for the middle, alpha is in the outside. If there's 95% inside, outside together is 0.05, or 5%. So 0.05 for the outside, comma, the standard deviation of 1.8 children, comma, in my sample size of 29 families. And when I do this on Excel, Excel is going to give me a value in error of 0.68. So for my confidence interval, we can take our point estimate. The average was estimated to be 3.2 children per family. And we'll subtract the error that we just found of 0.68 to get the lower bound, and take the point estimate of 3.2 and add the error of 0.68 to get our upper bound. And when I do, I get a confidence interval that we are between 2.52 and 3.88 children per family. In fact, let's interpret it using that same script we saw for interpreting a confidence interval with proportions. We can say that we are 95% confident the true mean children, actually we should say mean number of children, per family is between 2.52 and 3.88.